Hey, Computer Science 120. So I got some requests for some videos. I thought I could roll together two videos in a row that's going to talk about pointers, references, structs, and some other stuff. So what I've got here is my text editor open up to a file. It's called pointers and refs.cpp, and I've got my terminal set up to be in the same spot there. Let's get started. This is going to be a really interesting program to write. I'm going to declare a variable x. It's an integer. I'm going to set it equal to 42. Then let's print out what it is. Int x is, and I want to print out its location. Remember, I can use the ampersand operator to print out its location. So it should print out 42 and some location in memory. It'd be some hexadecimal number. Let me give myself a new line to give me some space when I print it out. Now, here's where I'm going to make a pointer, p. P points to ints, and if it points to ints, that means it can point to x because it's an int, but just not x by itself. It's really the address of x, because a pointer takes on the value of the address of the thing it points at, and I can dereference the pointer to get at what it points at. So let us print it out. So let's give ourselves some information. This way it's easier for us to understand what we're doing. If we go back and we look at our printout, we can figure out what exactly is going on in each line rather than just printing out things randomly. And I can just print out the value of p just by writing p, but it just will tell me the address that it's pointing to. And then I can also figure out where it's located. Sorry if I'm sniffling a little bit. I got allergies. So here I'm printing out what p is equal to, which would be the address of x. That's what I did on line 9. And then I'm going to print out its address. And its address has to be different than x's address because they're two different things. But let's see if we can get at what p is pointing at. Come on. Now, I'm using the word dereference to mean that I'm like following up and figuring out where it points at something. And that I'm using the star p to get at what it's pointing at. So p by itself is some address. Star p says go find that location in memory and get the stuff out of there. All right, so that's a pretty nice program so far. Let's compile it. So I'll say pointers and refs.cpp. No problems. Great. I run it. Okay. Int x is 42 and it is located at some address that ends in B938. Let's set int star p equal to the address of x. So star p is equal to B938. Notice it's the same value as x's address and is located at B930. So that's a different location than x. Two different things, two different locations. By dereferencing p, p points to 42. See, notice I used the star p right here on line 12, and I was able to get to the value of x. Now here's a new idea that some of you might have seen in 120, but probably a lot of you haven't seen, and it's kind of confusing. I'm going to say reference r. Now you know it's a reference r because this ampersand that I've highlighted here on line 15 is next to the type. The type here is int. It's an int reference. R is the name of that reference. I'm going to set it equal to x. So similar to on line 9 where I have a pointer p that's an int pointer that's pointing at x, I have a reference r, and the reference r is an alias of x. And I haven't assigned, like typically when I use the equal sign, you can say I assign this value to that. Here I'm binding x to r. That's a very particular term of art. So I shouldn't say set, let's bind. And now We're going to see what it is, just like we did with the other ones. Oh, I forgot my quote. Now I'm getting ahead of myself here. I just want to write this out, but we're going to see that in a second, that R is actually the same, has the same address as X. Why are my fingers not typing well today? Let's try this out. All right, X, and note that every time I run the program, things are going to be located in a different place in memory. Not a big deal. Let's set P equal to that. We saw that last time. Now let's bind R equal to X. So R is 42, and I forgot a space there. And it's located at, okay, what address is this? This address is not unique. This address, and here's why I want to write that, that address is the same as X. Here's some like black magic going on that the compiler is throwing at us. R somehow has the same value as X and somehow has the same location in memory as X, even though R is not X. This is kind of like this cool magical thing that you can use to your advantage in some places, but it can also make things rather confusing. So let's see, what else can we do? Let's see if we can make P point to R. So we got P pointing to X. We have R bound to X. Now let's set P equal to X. And I should say let's set it equal to the address of R because it is a pointer after all. So P is going to take on that address value. How do we do it? Same way we do it with X, right? P is equal to ampersand R. I can copy and paste this. Compiles. That runs. So we see X is 42. It's located at 8928. We set P equal to it. P can be dereferenced to get 42 out of it. Great. I can bind R. R is magically the same place as X. It can get the same value as X. Oh, I forgot to print out a nice blank line for organizing stuff. Now, I set P equal to the address of R, and it works the same way. But note that the address that it's pointing to is 8928, which is the same thing as X and the same thing as R. So P is pointing to X or it's pointing to R. That's not clear because here on line 23, I clearly said P is pointing to R, but it has the same value as the address of X. Weird, but it still works. Now, that's kind of clear. Why don't we then say I'm going to introduce another variable, int y is equal to 17. Now, can we do the same thing with y that we did with x? So int y is 17. It's located to some address of y. Great. And then why don't we do the same thing with pointing at pointing p to x, or p to y, I should say. So if I have p pointing to y, how would I write that? I would say p is equal to ampersand y. So it's the address of y. Let's start p as p and p is located ampersand p. What should we expect to see? I expect this part to print out a whole new variable that's equal to 17 at a different location, and I expect this to spit out something similar. That's going to be, oh, now I'm pointing at this other location and it's equal to 17. Let's compile and run. All right, so I have x is 42. X is located at D928. I do the whole P and R thing. And then, oh, I made a mistake. Let me fix that. I accidentally left the X over here. Ignore this. Make it go away. Let's compile. Let's run it again. So Y is 17. It's located at 5914, which is different than X. X is 42, and it's located at 5928. So 5928 versus 5914. Then I set P equal to the address of Y. So P is equal to 5914, which is the same address of Y. And if I dereference it, I get 17, as I expect. Cool. Now let's try doing this with R. So I want to try to see if I can have R bind to Y. We've already seen that I can bind R to X. So I'm going to do something similar to this. So let's fix this up. I don't need to redeclare it. It's already been declared. So I say R is equal to, not X, but Y. So here I'm rebinding it. Int R is R and is located at ampersand R. Notice that R is in the same address as, well, is it the same? Well, it should be the same address as Y. And print that out. Let's save this, compile it, and run. Okay, so up here, let's start with X. X is 42. It's at A928. Y is 17. It's at A914. We did the P part. That's fine. Worked as we expected. I want to bind R to Y. So R is 17. Cool. R is located at A928. Wait a second. Wait a second. Notice this. Notice that R's address is A928, and it's not the same address as Y, which is A914. This is a big difference between pointers and references. Pointers, you can reassign as much as you want. So that pointer P, I can set it to any integer. I can make it point to any integer I want, as much as I want. I can change it all the time. References, the ones with the ampersand, R in this case. Once it's bound to something, it's bound to that forever. You can't change it. So even though R is printing out 17, guess what we've done? What we have done is we've changed X. Let me show you what's going on. So how should we write this out? It has the same address, not of Y, but of X, right? We should say X, and we should say, give a better message. Still. Because it never changed. We expected it to change. No, I want to say, what just happened? Oops. So it never changed. What should we write here? Why don't we print out that X was changed back to what Y was? Well, it's not that it changed back. It's just that X was changed, not Y. Because we just set X equal to Y. R is an alias of X. Let me scroll down a little bit. So, why is this not indenting nicely? Sorry about all this. Great. So, let us print out what X and Y are right there. That's X. And that is Y. we have never, ever, ever changed X. We have never changed Y. We've only changed P and R. So I'm going to compile this. And here's what's going on. X is 17. How did this happen? Because R was bound to X. And we tried over here to set R to Y. But you can't do that because R is bound forever to X. So that effectively is the same thing as saying X is equal to Y. And that changed X to 17. That's the crazy thing about references. Now they're really cool to use because that means that they're like pointers, but they're not pointers. They're aliases. And you only can bind them once. Once they're bound, you can never unbind them. If you want to do a different thing, you just have to come up with a new reference. So that's kind of weird, but you can write this program yourself and go through it more slowly and try to decipher why pointers work a certain way and why integers work a certain way. Now I'm going to do the same program again, but instead of using ints, I'm going to use structs. And we're going to see some really interesting things going on. And if you got questions, of course, feel free to contact me via email, maybe set up an office hours appointment. But I hope this clarifies a little bit about pointers and aliases or references and all that stuff.